Hello everyone, this is Sudhir Nikhade and here I will present you 4 video lecture series on the AC voltage controller. So this is my first video lecture on the topic AC voltage controller. So in this video lecture we will cover the introduction of AC voltage controller, application, features of AC voltage regulator, the types of AC regulator and the types of control technique. Let's start the introduction of the AC voltage controller. So AC voltage controller are the thyristor devices which are designed to control the power flow to the load by controlling the RMS value of the AC voltage. AC voltage controller are designed by connecting the reverse parallel pair of the thyristor or track between the AC source and the load, as we can see by this circuit diagram. Here we are connected two ACR to thyristor parallelly in the reverse way. Also we can use the track in the AC voltage controller. AC voltage controller is a converter circuit which converts the fixed alternating voltage directly to the variable alternating voltage without change in frequency. It is also called as AC voltage regulator. There is also another converter circuit which is called as a cycloconverter circuit, which we will see in the next coming videos, which basically converts the fixed mains AC voltage to the variable alternating voltage but with a variable frequency. The applications of AC voltage controller. There are many applications of AC voltage controller, but I have mentioned some of the applications. So first one is a speed control of polyphase induction motor, domestic and industrial heating, lightning control, AC magnet control and on-load transformer tap changing. Now the features of AC voltage controller. I have taken this much advantages when I compared with the earlier controller technique using auto transformer and magnetic amplifier. As the AC input voltage in the AC voltage controller is AC, the thyristor used are line commutated and phase control thyristor, which are very less expensive. So as the line or natural commutations is used, there is no need of extra commutation circuitry required. The main disadvantage of this voltage controller is the presence of harmonics in the supply current side as well as the load voltage waveforms, particularly at the lower output voltage level. There are mainly two types of AC voltage controller. First one is a single phase AC regulator and second one is a three phase AC voltage regulator. Again in that single phase AC regulator there are two mainly types. The first one is unidirectional or also called as a half wave controller, and second one is a bidirectional or full wave controller. In the first type half wave controller we will use only one thyristor and one diode, and in the second type, in that bidirectional full wave controller, we will use two thyristors which are connected parallelly in the reverse. Before discussing the types of AC voltage controller, let's discuss the types of control technique. So for the power transfer there are two types of controls are used. The first one is the on-off control, which is also called as the integral cycle control, and second one is a phase control. We will see the first type, that is on-off control type, which is also called as the integral cycle control type. In that particular type, the load power can be controlled by connecting the source to the load for a few number of cycles and then disconnect the load from the source for the another number of cycles, and that procedure will repeat itself. That particular technique is suitable for a system with a very large time constant, because in some industry there are some applications which will require a time constant is on the order of several seconds. It also provides the average power to the load from 0 to 100%. In the on-off control technique, basically we will use the bidirectional controller circuit. Bidirectional control circuit means we have to use two thyristors which are connected parallelly in the reverse way. So this is the waveform for the on-off control technique. First three cycles are connected the load to the source, and the next two cycles disconnect the load from the source, and that procedure will repeat itself. In the second control type, it is AC phase control type. In that particular control technique, the thyristor switches connect the load to the source for a portion of each cycle of the input voltage. In last case, what we have seen in the on-off control technique, The thyristor switches connect the load to the source for a few number of cycles and then disconnect the source from the load for the few number of cycles. But here we have to connect the load to the source for a portion of each cycle of the input voltage. The power flow in that control technique is controlled by delaying the firing angle of the thyristor. And the circuit which is used is the single phase half wave controller, which is also called as a unidirectional controller. And this particular control technique is suitable for the low power ratio load like heating and lighting. This is a circuit, simple circuit for the AC phase control. In the next video we will see the types of AC voltage controller, the 3-phase AC voltage controller. So what we have seen up to now, we have seen the introduction of AC voltage controller, we have seen the types of control technique, we have seen the applications and features. So in next video we will see the types of, in detail, the types of AC voltage control. Thank you for watching this video.